In this video, we're going to take a look at a Leetcode problem called Subarray Sum Equals K. So given an array of numbers, integer numbers, and an integer k returns the total number of contiguous subarray whose sum is equal to k. So here you can see we have an array of integer numbers, right? So in this case, k is equal to 2, and in this case, we can form this subarray. Right, two ways to form this subarray where the sum of those subarray is equal to k. So we can have those ones, right? So in this case, 1 plus 1 is equal to 2. So that's one subarray that has a sum equal to k. And the other one is this one right here, where the sum is also equal to k. So in this case, we have two ways to form a subarray that has a sum that's equal to k. And if we have something like this, same thing, we can have 1 plus 2, or we can have just 3, right? So in this case, both ways are valid, right? A valid subarray that has a sum that is equal to k. So in this case, we return 2, right? So there are two ways to two contiguous subarray where their sum is equal to k, right? So let's take a look at how we can solve this problem. Now, one way we can do this is we can use a nested for loop or three for loops to solve this problem, but the idea is the same. We're basically going to, for each and every single subarray from I to j, I is basically the outer for loop and j is the inner for loop. And then we're just going to check to see if the sum of the subarray from I to j is equal to k. So let's say we have an array like just the previous array 1, 1, 2, and 3, right? So the goal is we have to iterate starting from here to here, from here to here, from here to here, right? And then from here to here, and from here to here. And for each of those subarray, right, we're just going to check the sum. Then we check to see if the sum is actually equal to k. So here you can see we have a sum that is equal to 1, right? So does 1 equal to k? In this case, 1 does not equal to k. So k is 3. 1 does not equal to k. Well, let's try 1 plus 2. 1 plus 2 is 3. 3. In this case, the sum is equal to k. Then we increment the counter by 1. And then 1 plus 2 plus 3, in this case, we have a sum that is equal to 6, which does not equal to k. So in this case, we continue. Now we have 2 plus 2 it does not equal to k, and 2 plus 3 is 5. 5 does not equal to k, and 3 in this case is equal to k. So we have two outputs. So output is 2, right? So that will give us a n squared to n to the power of 3 time complexity. The idea is the same. For n squared, we're going to use a current sum variable, basically track the sum from nums I to nums j. Instead of just like iterating each and every single element from I to j, we're just going to use a current sum variable to keep track of that, right? So that's one way. One way is to use a nested for loop. Now the other way we can do this is we can use a prefix sum. So the idea of prefix sum is pretty simple. So if we have given an array like this, 1, 2, 4, 1, right? So we have index is above, and we have a prefix sum. Prefix sum is basically the sum of the subarray from index 0 all the way to the current element. So let's say we have an array like this, and the prefix sum for the first element is going to be 1, right? In this case, 0 to 0, the sum of subarray from 0 to 0 is 1. So that's why we have a 1 here to represent the sum of the prefix sum from 0 to 0. This represents from 0 to 1, the sum from 0 to 1, right? It's going to be 3. 1 plus 2 is 3, right? And 7 is going to be the prefix sum from 0 to 2. So we have 1 plus 2 plus 4, which is 7. 8 is going to be the prefix sum for this element right here. And why do we have a 0? Well, I'm going to show you why we have a 0 in a second, but first, I want to show you something very, very important. Okay, so if we want to know the sum of the subarray from I to j, right? Sum of the subarray from I to j, what we can do is we can use the prefix sum at j plus 1 minus the prefix sum at I. Because the reason why we use this is because the prefix sum at nums at I, right? The prefix sum at nums at I, let's say I is equal to 1. This is nums at I, right? The prefix sum for this element is actually going to be I plus 1, right? And the j is going to be, let's say j is index 3. So the prefix sum is actually just going to be j plus 1, which is prefix sum at j plus 1. But why don't we have I plus 1 instead of I? The reason why we have that is because of this that I show you here, this diagram that I show you here. If you think about it this way, we have prefix sum at nums at j. So nums at j, the prefix sum for nums at j is going to be nums at 0 plus nums at I minus 1 plus nums at I plus all the way to nums at j, right? We know that j is going to be bigger than I, right? Because the j is going to be the inner for loop and the I is going to be the outer for loop, just like the brute force that we talked about. So in that case, we have j plus 1 is going to be the prefix of nums at j, just like I would talk about. If j is 3, the prefix sum of j is going to be 8, right? In this case, it's going to be a prefix sum at j plus 1. But why we have prefix sum at I instead of I plus 1? The reason is that if we want to get the sum of the subarray between I to j, all we need to do is we need to remove this subarray, the sum of this subarray, in this case, this prefix sum of nums at I minus 1, right? If we remove the sum, in this case, if we remove the prefix sum of nums at I minus 1, remove the prefix sum for nums at I minus 1, we get the sum of the prefix sum, or I should say the sum of the subarray from I to j. Because those two, we can just remove that. We just basically get the prefix sum at j plus 1 minus prefix sum at I, because nums at I minus 1, the prefix of this is going to be prefix sum at I. So if we remove those, right, if we remove this, I should say if we remove this, right, from this prefix sum at j plus 1, we can be able to get this part, right? That's all we need, the sum of the subarray from I to j. So from that, we know that that's why we have a 0. We need a 0, because the thing is that if we need to get a sum from, let's say here to here, right? From here to here, j is 2, j plus 1 in this case is going to be 3. So we have this one right here, 7. 7 minus prefix at I. So prefix at I is 0. So in this case, we don't have we cannot include this element, right? So in this case, we need the prefix sum for nums at I minus 1. So that's why we have 0. So 0 is basically the prefix sum for nums at negative 1, right? So that's why we have 0 here, which give us 7. Because this, right, this is we want to know the subarray, sum of subarray for those 3 elements. In this case, we have 7. And now let me give you another example why this formula works, right? Remember, we're getting the sum of subarray from the prefix sum, right? And the prefix sum, because we have 0 here, is going to be 1 to the right, right? The index is going to be 1 to the right. So in prefix sum at I is basically the prefix sum for nums at I minus 1. Now let's say if I want to get the prefix sum for those 2 elements, in this case, the prefix sum for those 2 elements is going to be j, right? So prefix sum at j is going to be 7 minus prefix sum at I, which is going to be 1. 7 minus 1 is 6. 2 plus 4 is 6, right? So it makes sense. And now let's say if I want to get a prefix sum for 1, so from those, so this subarray right here, right? So in this case, we get prefix sum at j plus 1, which is 4. 4 in this case is going to be 8. 8 minus prefix sum at I. And I is going to be 1, right? So in this case, I in prefix sum is going to be 1. So in this case, we have 7. 2 plus 4 plus 1, you get an idea, right? So how can we solve this problem using the linear time complexity approach? But first, let me summarize what I just talked about, right? And what I just talked about is this. If we want to get basically the prefix sum for nums at I is going to equal to prefix sum at I plus 1, okay, because we have a 0 element there. That's one thing. The other thing is that we have, if we want to see if there is if we want to know the sum of two subarray, from 2 points from I to j, we want to know the sum of the subarray from I to j, we just got to do prefix, right? So let's make PS short for prefix. PF at j plus 1 minus PF at I. This will give us the sum of the subarray, right, from I to j. All we have to do is we have to see if that is equal to k. If that is equal to k, then we found a subarray sum that is equal to k, right? So we can just increment our counter by 1. But how can we do this using a linear time approach? What we can do is we can use a hash table, right? We can use a hash table, and basically we want to know how many pairs of I and j where I is less than j, and prefix j minus prefix at I is equal to k, or in other words, j plus 1, because in this case it's going to be nums at j, right? The prefix of nums at j minus prefix of nums at I. If the prefix at nums at j is minus prefix nums at I is equal to k, then we can just increment the counter by 1, right? How many pairs can we get? So in this case, we can flip the formula, right? We can say the prefix sum for nums at j minus k. Do we see a prefix sum at nums at I somewhere in the hash table? If we see it, we increment it by 1. If we don't see it, we're going to continue to iterate. Okay, so here you can see we have a given array. In the case 7, this is going to be the prefix sum for the array above. So we have 0. So 0 is the key, right? Key, and the 1 is going to be the value, how many times this sum appeared. So before, in this case, the sum initially is going to be 0, and we appear once, right? So now we have 3. So 3 is going to be the first sum, right? So we have sum 3 and then appear once. Now 3 is going to be the prefix sum j, or I should say the prefix sum of this element, right? So prefix sum of this element right here minus k. Do we see a prefix sum of num at I somewhere in the hash table? In this case we do, because in this case we don't, because 3 minus 7 is equal to -4. -4 does not contain in the hash table at all. We basically just look at the prefix sum in the table, and now we have 4. 4 minus 7. Do we see a -3 somewhere in the table? So this is the prefix sum for this element, right? So for this prefix sum, do we see a 7 minus 7? Do we see a 0 in the table? In this case we do. So in this case we just put here, and then we're just going to increment the counter by 1. So now we have 1. Okay, so in this case we have 14. So because 7, right, the prefix sum for 7 is 14. 3 plus 4 plus 7 is 14, right? So 14 minus 7, do we see a 7 somewhere in the table? In this case we do. Okay, so we do, and then what we have to do is we're just going to increment that by 1, right? So in this case we see 1 there, so we're just going to increment that by 1. Okay, which makes sense, because what we can do is we can have the sum. So now we're just going to add 14 onto our table because we've seen it, and there's only a pair once, right? So now we have 2. So 2, in this case, we have a prefix sum of 16. So 16 minus 7, do we see so 16 minus 7, do we see a 9 somewhere in the table? In this case, we don't. So in this case, we continue. And -3, do we see, so -3, so we have a prefix sum of 13. 13 minus 7, do we see a 6 somewhere in the table? In this case, we don't. Sorry, yeah, we don't. So we're just going to continue, right? So 13 right there. And then we're going to have a prefix sum of 14. Do we have a 14 somewhere in the table? Yes, we do. Then we're just going to increment that by 1, and then now we have 14 appear twice. Okay. And what we're going to do is we're just going to say, well, the prefix sum for 4 is going to be 18. So 18 is going to be 1. Okay, so do we see, so 18 minus 7, do we see a 11 in the table? In this case, we don't. So now we have 20, right? The prefix sum of 2 is 20. So 20 minus 7, do we see a 13 in the table? In this case, we do. Okay, so in this case, we do. We have 13 right there. So we're just going to increment that by 1. Okay, which makes sense because in this case, what we can do is we can have 1 plus 4 plus 1, which is 7, right? So that's one subarray. And we can also have 3 plus 4, which is one subarray, and 7 is a subarray. And what we can also do, 7 plus 2, which is 9, 9 plus negative 3, which is 6. 6 plus 1, we have a 7 right here. 7 plus 2 plus negative 3 plus 1, which also give us 7, right? So in this case, we have 4 answers, okay, 4 answers. In this case, we're just going to return 4. So now you might be asking, like, why do we need a hash map for this? All we had to do is we just see an element and we can just increment that by 1, but that's not the case here. Let's say if we have another 1, right? So this will make a 21. 21 minus k in this case is going to be 14. So we see another 14, right? So in this case, 14 is in the table and 14 appeared twice. So in this case, do we just increment that by 1, like just plus 1 here? This will give us 5. Like, is that our answer, or do we have to increment it by the times that this element appeared? In this case, this element appeared twice. Well, let's take a look. So in this case, we have, right, we can have 3 plus 4, or 7, or, yeah, 7 plus 2 plus negative 1 plus, sorry, negative 3 plus 1. That's 1. That's another one. So far we have 3. And the other one is going to be 1 plus 4 plus 2, and the other one is going to be 1 plus 2 plus 4, right? So 1, 2, 3, 4, 5. So far we have 5. Where is the other one? Let's see. We can also have 2 plus negative 3 plus 1 plus 4 plus 2 plus 1. Yeah, I think that will also work because in this case we have 2 plus negative 3, which is negative 1. Negative 1 plus 1 is 0. 0 plus 4 plus 2 plus 1 also gives us 7. So in this case, we have a total of 6. So now let's take a look at how we can do this in code. So to do this in code, let's try to create our hash map first, right? So we're going to have a hash map. Integer is going to be the key of the prefix sum, and the value is going to be how many times that element appeared, that prefix sum appeared, right? So is equal to hash map. And then we also have a prefix sum, so the current sum, right? So the current sum is equal to 0. And then initially we're going to have a 0, 1, right? That's basically for saying that we have a prefix sum 0 that appear once, okay? So in this case, we have hashmap.put. And we have 0 appear 1 time. So we're not going to have the prefix sum array like this. We're just going to increment it as we go. That's why we need a current sum here. The current sum basically keep track of the current sum that we have, right? If you notice here, we have 0, 3, 7, 14, 16, 13, 14, 18, and we probably should have 20 and 21, but basically you get an idea. We have a hash map to keep track of the prefix sum, right? Or we should say we have a variable that current sum, which keep track of the current sum. So we don't need an array. We can just keep track of the previous element and just save it onto a hash map. So we're just going to iterate starting from the first element, less than nums.length. And what we're going to do is we'll have to update our current sum. So current sum is equal to, is basically equal to current sum plus nums at I, right? Once we have updated our current sum, what we're going to do is we're going to get our other prefix sum, right? So in this case, the prefix sum for nums at I that we just talked about is going to be, so in this case, it's going to be, so prefix sum, the other prefix sum, let's say prefix sum number 2 is equal to current sum minus k. And then we're going to see if PS2, right, is actually equal to K. If it contains in a hash map. If it is, then we know that we're just going to get the counter, right, plus equal to, or counter is equal to counter plus the number of appearance for that prefix 2, right? So we're going to have a counter variable, and in this case, hash map contains key PS2. If it contains this element, we're just going to increment the counter by the hash map get PS2, right? The prefix sum 2, right? The other prefix sum. And and then what we're going to do is we're going to get increment the number of appearance for the current sum, right? So hash map put current sum, and we're just going to say hash map get or default, right? So current sum, and it's going to be 0 by default. We're just going to plus, every time when we see this element, we're just going to increment up element by 1. So then at the end, we're just going to return the counter. Okay, so now let's try to run our code and try to submit. You can see we have our success. So this is how we solve this problem using a linear time complexity.